Assalamu alaikum. Safina High School Mathematics Kcse 2017. We are going to attempt this question using the matrix method. We are told here that a construction company employs technicians and artisans. On a certain day, 3 technicians and 2 artisans were hired. And on that day, they were paid a total of 9,000 shillings. On another day, the firm hired 4 technicians. So 4 technicians and 1 artisan, and this was for a total of 9,500 shillings. We are asked to calculate the cost of hiring 2 technicians and 5 artisans in a day, but we cannot calculate the cost of hiring 2 technicians and 5 artisans before we first find out the cost of hiring 1 technician and 1 artisan. So in short, what this question requires us to do is to find the value of T and the value of A. How much is a technician paid in 1 day and how much is an artisan paid in 1 day. When we have calculated the wages of the technician and the artisan, we can now proceed to calculate the cost of hiring 2 technicians and 5 artisans. So without wasting time, let us attempt this question using the matrix method. We shall first place a matrix here where we include only the coefficients. Coefficient of T in the first equation was 3 and coefficient of A was 2. And in the second equation, the coefficient of T was 4 and the coefficient of A was 1. And then we have another matrix here that shows us the variables. The variables in these equations were T and A, the cost of hiring a technician and the cost of hiring an artisan. And on the other side of this equation, the right hand side, we had the total cost of the first day, which was 9,000 shillings, and the total cost of the second day, which was 9,500 shillings. Normally, we multiply rows times columns to get answers. So in this first equation, 3 multiplied by T, you see I'm taking this direction from the first row, 3 multiplied by T, and then 2 multiplied by A. So I'm taking this direction from the second matrix so that I can multiply rows times columns. 3T plus 2A is equals to 9,000, and in the second equation, rows times columns is equals to answers. So 4T plus 1A is equals to 9,500. It has been arranged properly. We can now proceed to find the cost of hiring a technician and the cost of hiring an artisan. So we have a matrix here with coefficients, and we have a matrix with variables, but we just want to be left with the value of T and the value of A on the left hand side, and on the right hand side we want the answer for what is T and what is A. So on the left hand side, what can we do to remain with only T and A? We need to find a way to get rid of the coefficients before it. How can we get rid of these coefficients? Let us try something here. We'll add the inverse of this matrix here before the matrix. And then, because we have added it on the left hand side of the equation, we'll also have to add it on the right hand side. But let me not confuse you. Let us go step by step. First, we write this same matrix the way it was. So 3, 4, 2, 1. And then we add the variables just the way they were, T and A, is equals to, here we leave some space because we are going to utilize this space before here, and we are also going to utilize this space here. And then we write the same matrix that was there for the answers or the total costs. So 9,000 here and 9,500 here. Now we are going to add something here that will get rid of this matrix so that we can be left with only T and A on the left hand side of our equation. But when we add it on this side of the equation, sorry about that, when we add it on the first side of the equation, we are also going to need to add it on the second side of the equation, so that what we have done to one side is repeated on the other side and our equation remains as balanced as it was. So what are we going to add on this side that will get rid of this equation? We are going to add the inverse of this coefficient matrix on this side, so we will get rid of the coefficients on the left hand side. How does the inverse look like? The formula for inverse is equals to 1 over the determinant multiplied by the adjoint. 1 over the determinant multiplied by the adjoint. So 1 over the determinant is on this side. We'll also add it on the other side. 1 over determinant times the adjoint we added on the other side. 1 over determinant times the adjoint. How do we find the determinant? Determinant is found from this equation by taking the leading diagonal or the product of the digits in the leading diagonal and then subtracting the products of the digits in the trailing diagonal. So this is the leading diagonal and this is the trailing diagonal. In the leading diagonal we have 3 and 1. So we take the determinant as 3 times 1 and then minus the digits in the trailing diagonal are 2 and 4. So we multiply this by 2 times 4. 3 times 1 is 3 minus 2 times 4 is 8. So 3 minus 8 will give us negative 5. 3 minus 8 will give us negative 5. And here now we have our determinant. Our determinant is negative 5. We can place it here outside the adjoint. So 1 over negative 5 on this side and 1 over negative 5 on the other side too. And then how do we fill in our adjoint? In the leading diagonal we switch the position of the digits. So between 1 and 3, 1 will take the place of 3 and 3 will take the place of 1. And then between 2 and 4 in the trailing diagonal we do not switch the places. We do not switch the positions. We leave them the way they were. 2 remains where it was and 4 remains where it is. But we change the sign in this number. So if we had 2 here, we write a negative 2. And here because we had 4, we'll change it to a negative 4. If we had negative in the first equation, in the first matrix, in the adjoint we'll have its opposite, which will be a positive. So whatever we added on this side, we also have to add on this side. Here we can say 1 over, or no over there, 1, negative 4, negative 2 and 3. What we added to the left hand side, we also added to the right hand side. Please be careful because we pre-multiplied on this side. On the other side we will also have to pre-multiply. You can watch our video on matrix multiplication to know why it is necessary to pre-multiply on both sides and not mistake pre-multiplying for post-multiplication. So we have pre-multiplied on the first side and on the other side. What will happen on the first side, which is the left hand side of the equation, is that all this, the inverse times the matrix, will disappear and we will only be left with our coefficient matrix, which has T and A. T and A. If you want to learn how to multiply these matrices, please watch our video on matrix multiplication. On the other side, we shall be left with 1 over negative 5, and then these two matrices here will be combined. The first matrix times the second matrix will give us a new matrix. And because in our first matrix we had a 2 by 2 equation, a 2 by 2 matrix, and in our second matrix we had a 2 by 1 matrix, meaning 2 rows, 1 column. We can multiply these matrices because 2 and 2 here are similar, and our answer will be a 2 by 1 matrix. The number of rows in the first matrix and the number of columns in the second matrix is what will make our resultant matrix. So 2 rows and 1 column, we have placed enough space for that. Now we can multiply. Rows times columns. 1 times 9,000 is 9,000. Negative 2 times 9,500 is negative 19,000. When we take 9,000 plus negative 19,000, we shall be left with negative 10,000. Please watch our video on matrix multiplication to make sure you know what you are doing when you come to this step. In the second equation, we shall take again rows times columns. So negative 4 times 9,000, which is negative 36,000, plus 3 times 9,500, which is 28,500. Now we take negative 36,000 plus 28,500, and we shall be left with negative 7,500 shillings. And that is our answer in the second row. Remember, we had 2 rows but only 1 column in our resultant matrix. Now let us complete our answer to get, let us complete our working to get the final answer. T will be 1 over negative 5 times negative 10,000, and this will leave us with 2,000 shillings. And A will be 1 over negative 5 times negative 7,500, which will give us 1,500 shillings. Now we know that the cost of hiring an artisan per day is 1,500 shillings, and the cost of hiring a technician per day is 2,000 shillings. If you want to know what technicians and artisans are, you get below a D plus or get below a C minus in Kcse, and these are the courses you will do. They are not bad courses, but you can go higher than that. Instead of going for a technician course or an artisan course, you should do this as a side hustle, and you go for a degree course or a diploma course in any of these technical fields or theoretical fields. The choice is yours. Please work hard. Make sure you do well in your Kcse exams, and may God be with you. So the technician is paid 2,000 shillings and the artisan is paid 1,500 shillings. Let us go back here. Calculate the cost of hiring 2 technicians and 5 artisans in a day. How much is a technician paid and how much is an artisan paid? So when we go back here, we want to the cost of hiring. How many technicians and how many artisans? 2 technicians and 5 artisans. So we want the cost of hiring 2 technicians and 5 artisans. But we now know the cost of hiring 1 technician and 1 artisan. So the cost of hiring 2 technicians will be 2 times 1 technician is paid 2,000 shillings, plus the cost of hiring 5 artisans will be 5 times 1 artisan is paid 1,500 shillings. I know these have started getting easy from here. 2 times 2,000 is 4,000, plus 5 times 1,500 is 7,500 shillings. When we take 4,000 plus 7,500 shillings, we shall get 11,500 shillings, and this will be the cost of hiring 2 technicians and 5 artisans on that day. If you need more help, please feel free to contact us on WhatsApp 0717 588 568. This is our WhatsApp number. We're located in Kenya, so you should start with the code +254. if you are trying to text us on WhatsApp. So 0717-588-568. Feel free to go through our other lessons on matrices. We have lessons on the whole Kenyan high school curriculum, Kcse, and we are hoping through our channel you can raise or you can soar to higher heights and you can do well in your exams wherever you are watching us or wherever you are following us anywhere in the world. We wish you all the best and may God be with you. Thank you for paying attention. All the best. Ahsantum.